Hi everybody, this is Mr. Adams and I'm going to be walking you through some of the review problems. So we're going to start in with number 28, and I see that I'm talking about inverse functions. So the key thing here is that these have to be functions. So I know that my graph of sine inverse looks something like this. It's going to start at 0, increase to 1, go back to -1, so on. And I can tell that this is nothing like a function because it fails the vertical line test all over the place. So we're going to restrict the range and make it so that it's a function. Now I know that sine hits +1 here at pi over 2. I know it hits -1 down here at negative pi over 2. So that's going to give me the range. So my range for sine is going to go from negative pi over 2 to positive pi over 2. And my domain, of course, goes from -1 to +1. Now, for cosine, it's almost exactly the same thing, except my cosine function actually starts out at 1 and starts decreasing down to -1 and so on. So now I have to restrict the range to go from 0, and cosine hits -1 at pi. So this time my range is going to go from 0 to pi. And of course my domain is going to be the same exact thing. So my cosine domain is -1 to 1. Now for tangent, it's important to remember that tangent is sine divided by cosine. So every time cosine is 0, you're going to get an asymptote. So our range here only goes from negative pi over 2, strictly less than y, strictly less than pi over 2. It can't touch pi over 2 because we've got the asymptote. And the domain is all real numbers since it's sine divided by cosine, so we can have some fairly large numbers. Now moving right along, number 29 is kind of similar to what we just did in 28. So in 29, I notice in A that I've got asymptotes. That tells me it's got to be tangent. The next one, I see that it's starting right at 0. When I input 0, it outputs 0. The only function that does that is sine. And I see that this function started at 1. When I input 0, it output 1. So that tells me this must be cosine inverse. Now, looking at the next problem, I see that I've got to evaluate a bunch of different trig functions. So the first one asks me to evaluate where sine inverse gets to be 1/2. So I'm looking for the angle or the radian where sine would be positive 1/2. Now, sine is only positive in quadrants 1 and 2, and I know that sine inverse only goes from negative pi over 2 to positive pi over 2. So my answer here can only be in the first quadrant. And the only spot in the first quadrant where that happens is pi over 6 or 30 degrees. Now in letter B, I see I've got -1 over root 2. So I'm going to start by simplifying that because I can't have a square root in the denominator. So I wind up with -√2 over 2. And I'm looking for where cosine is negative. Well, cosine is negative in quadrant 2 and 3. But I know that the inverse only exists between 0 and 180. So my answer has to be in quadrant 2. And the spot where this happens in quadrant 2 is 3 pi over 4, which is also 135 degrees. Anytime you see the root 2 over 2, that's always got to be one of the 45, 45, 90 triangles. Now, I see that I'm looking for where tangent is positive. That's only possible in quadrants 1 and 3, and only quadrant 1 would be in the inverse tangents range. So my answer has to be in quadrant 1. So this can't be one of the 45, 45, 90 triangles since tangent is 1 there. So this has either got to be pi over 3 or pi over 6. Now I could eliminate one of those by trial and error. I know that it winds up being pi over 3. If you try out pi over 6, you'll notice that it doesn't work. You'll wind up with root 3 over 3, which you obviously don't want. Now, in the next one, I see sine is again negative. So that tells me my answer's got to be in quadrant 4, since, again, sine inverse only exists in quadrants 1 and 4. So this would give me negative pi over 3. Next, I see cosine is positive, so I know I'm in quadrant 1, and this must be pi over 3. Now I see tangent is 1, negative 1 to be a little more precise. So that must mean that my answer is in quadrant, pardon me, that must mean that my answer is in quadrant 4. Because remember, tangent inverse only exists in quadrants 1 and 4, and quadrant 4 would be the only spot where tangent is negative. This has to be the 45, 45, 90 triangle, so that tells me negative pi over 4. Now next I see sine inverse of negative 1. Well, there's only one spot in the unit circle where sine gets to negative 1, and that's at 3 pi over 2, or 270 degrees. I can't write that, though, because 3 pi over 2 is technically outside of the range of sine inverse. I have to write negative pi over 2. Even though they're technically the same thing, 3 pi over 2 is outside of the range. We can't write that. Next, cosine inverse of 0. So cosine inverse, remember, it only exists in quadrants 1 and 2, so this would be pi over 2, since 3 pi over 2 wouldn't be in the range. And then I see tangent inverse of 0. Remember, tangent is sine over cosine, so if tangent is 0, then sine must have been equal to 0, so that tells me the answer there has to be 0 degrees, or 0 radians. Now, letter J, this is getting a little bit tougher. I'm going to evaluate the sine inverse of root 3 over 2 for starters. So the sine inverse of root 3 over 2, I must be looking for where sine is positive, obviously, and it hits root 3 over 2 at pi over 3, so I'm really being asked to find the cosine of pi over 3, and that, of course, winds up just being 1/2. Remember that you can always draw your special triangles if you forget any of this stuff on the unit circle. Now next I've got the tangent inverse of negative 1. We already found that that was negative pi over 4, so I'm really finding the sine of negative pi over 4. Remember, we just covered that in the last page. And the sine of negative pi over 4, so that's the 45, 45, 90 triangle, and it's in quadrant 4, so it's negative root 2 over 2. Now next I see I've got the tangent of the cosine inverse of negative 1 over root 2, and we just covered that one, so this is really the tangent of 3 pi over 4. And the tangent at 3 pi over 4, well, that's the 45, 45, 90 triangle, and it's in quadrant 2, so tangent would be negative. So it's going to be negative 1. Now next I see I've got the cosecant of 5/8. I'm going to change this and rewrite it as the sine of sine inverse of 5/8. And now I know sine and sine inverse cancel out, so this is just 5 over 8. Now next I see I'm taking the inverse tangent of 12 over 13. Pardon me, the sine inverse of 12 over 13. So if I draw my triangle, I know this is 12, this is 13, and using the Pythagorean theorem, I know that's 5. And I know that tangent is opposite over adjacent, so this would be 12 over 5. Last but not least, the cosine of 11 pi over 6, well, that's root 3 over 2. So I'm looking for the cosine inverse of root 3 over 2, and that, of course, is pi over 6.